Hey folks, here with Dave Hornak and John Franchi. We're talking about Biomerics capabilities in single-use endoscopes. Guys, I know that over the last couple of years, there's been a trend to move from multi-use endoscopes to single-use endoscopes because of the time for processing, the potential for bacteria infections. And so a single-use endoscope, much like the work that you do in complex steerable catheters, also has to have some articulation and steerability. And I understand that you developed and have a patent on the backbone or articulation member of a single-use endoscope that you can share with us, Dave.
That's correct. This was born out of necessity to reduce cost. We saw that the cost of getting the bending section from our supplier that we were working with was very costly. Sometimes the lead times were very long, and we just, as a laser cutting facility, we saw that there was an opportunity that we could produce something very similar to what they were getting, but in a much easier manner to procure it in. And so we came up with this design, two tubes, tube within a tube, and you can see how it will move within it. You've got a puzzle piece up here. It's captured within two tubes, and we laser weld here, so we use our laser welding ability as well as our laser cutting. So this is a Hypotube within a Hypotube, two sizes that fit within a tight tolerance that we can then manufacture and produce at a pretty inexpensive cost on this.
John, if you used a laser cut Hypotube and put a cut pattern in for a solution like this, I think you might be limited with the degrees of articulation. But it seems like here you have multiple degrees of articulation.
Yeah, that's right. So most of these are made using either MIM parts, machine parts, and they end up being complicated and costly, and you have to stack them up, assemble them, snap them together. If you're trying to get your control wires, you may have to drill holes, small holes, so very complicated. And what we wanted to do was kind of make something, as Dave said, out of tubing. And tubing Hypotube is very inexpensive. But what we do is, by creating an inner and an outer, we were able to basically create the features that you might have in a machine part, but simply by putting some of those features on the inside and some of them on the outside. Everything including locking features, everything including cable management. And you're absolutely right. If you try to do this out of one tube, as soon as you try to get four axes of motion, the assembly falls apart. It's just there's too many ways for the pieces to come apart. The locking design with inner and outer, you've got one part of it locking it from moving in one direction, and the other part of it locking it so that it rotates. And that just made it relatively simple to manufacture. There are some features that we're able to put into this, like cable management on the end that we're seeing right now, as well as cable management throughout, where you're seeing the little hoops there. Those are all part of the laser cut Hypotube section. And we can take these and assemble them, and just with tacking them together to just prevent them from moving around relative to one another, we're able to make this assembly, which is extremely versatile, extremely strong. The welds do not take any of the stresses. The stresses are all held by the interlocking puzzle type of architecture.
Interesting. Yeah, the welds are only there really to hold it together from one tube falling apart from the other. The other thing taken into account with these pull wires is that it's a four-way steering on this, but there's no welding on those as well. Just the weld is just to hold it in place. All the strength of the wire comes from the bend that you see on the end of that.
And with this design, we can make it bigger, we can make it smaller, we can use different Hypotube sizes, we can make different angles that it can articulate through. we have a way of manufacturing it so that when we do weld it together, we can pin each part, and that also lends itself to high production automated manufacture. We could feed these into a bowl and have them all put together and welded together, make sections as long as we want, as small as we want. We can make the end sections just slightly different so that they can attach to either the proximal or the distal end of the mating component.
Interesting.
So what you see is the holes into there on both the inner and outer rings. We put locating pins through, and we can weld the whole link assembly up with one fixture, tooling all of them together, and then programming the welder to weld each one of those individually. So,
can you talk a little bit about how this sub-assembly can be integrated into a full single-use endoscope with the additional capabilities that you have within Biomerics?
Sure. So, so we can then put onto the end of this. You can, what you're seeing right here, you can put on the distal end. You can put whatever you want. You can put a machine part. You can put a plastic part. You can put another 2-part that would hold your camera, working channel, LEDs, and on the other end, you can put something that holds your coil pipes that you need, and the rest of your laser cut Hypotube, braided shaft. So now you've got this section that can be put right in between. It gives you the articulation, but then you are attached to another longer section. You can then do a sheath over the top of it. You can do whatever you want over the top of it, and
and all those other things can be done within the Biomerics family. The other facilities can do the braided shaft for us, and we can do the laser cut Hypotube that extends further down from this. That'll house the coil pipes.
Yeah, we can go all the way back to the handle and the articulation features in the handle. So, being that Biomerics does do finished devices, this is kind of, as you said, this is the backbone. We have other facilities that can put on each thing that we need. We can even do final assembly down in a low-cost country like Costa Rica, and this can go, be packaged and sterilized and sent wherever.
Excellent. Thanks, guys.